Okay, so here we are going to be demonstrating the process of translating my images and data into a 3D point cloud. So first for our data generation code here, some things of note is a different color mask here. This was adjusted using the color picker code from an earlier time in this class. And basically, I went through and made an optimized upper and lower bounds to be able to detect just the laser out of my image and just like the image that it was producing on my camera. So these values worked for all of our images. We took 4 separate scans, and this upper and lower bound works for all of them and applies to all of them. Our RO and RPC values from an earlier assignment as well, where we calibrated our laser. So this will translate those images into a plot of XYZ coordinates for us and put them in a text file. Um, one of those images you can see here, it's rotated a little bit, but down here is the bench that I was scanning. It spells hope underneath. And you can see a little bit of the H here and the O here. And one thing that I want to point out in this image specifically is that these letters have depth to them, and you can see this curvature inside the O from the laser, so that's going to be really cool to see how our 3D point cloud picks up on that. So next I ran that code in Anaconda for all 4 of our scans and generated text files for all of them. Here it takes a little bit while, so I did that ahead of time. Um, and then I used the original LiDAR 3D point cloud code to be able to see where I needed to filter and cancel out noise and stuff. So this is a new script that I generated for a combined 3D point cloud for all of my scans total. So as you can see here, we import all of our text files and then we extract the data and assign them um, to XYZ variables. We then adjust for noise, like as you can see in A here, anything to the left of -12, anything to the right of 12, and anything above 3 we took out. That's just from noise from the background of the scenery. It could either be from getting the floor in the image, it could be from getting a little bit of the bushes behind it or the wall behind it. So we wanted to filter out some of that noise so we could get the best possible 3D point cloud out of this. We then translate and rotate all of them into position so that they line up correctly in the final 3D point cloud, and then we bring it back into an XYZ space to be able to plot. And we do this for every one of our scans, so all 4 of them. And then we print out our 3D point cloud. So now we're going to run the code and see what it produces. All right, let's take a look. So this is our hope bench here. So as you can see, it spells out the word hope as the legs. You can see this upper ledge, upper shelf here where the seating comes into play. And then you can see on this side, it's a flat face because the H here has an entire wall going up for the leg. But if you can see on this side that this E here, it has some spaces in it and a couple places where our laser couldn't pick up any of it. So you can see there's some spaces in there to account for the different legs of the E here. But again, you can still see this upper shelf here. And then as we noted earlier in the other image, we can see right here that curvature inside the O, which I think is a pretty neat thing to be able to pick up so that you could see that these letters do have depth as well. And then you can see down here that you can see the floor in some of them and also some of the inside of the other letters as well. So yes, this is the 3D point cloud that was generated. If you here, I can pull up the image as well for comparison. Here. This up for you. So here we can see the image here. So this is a picture of the bench, and here is our point cloud. As you can see, it picks up the depth in here. It brings out all of the letters as well. And you can see these empty spaces on the E side as well as this on the H, the flat side here. All right, and that is my generation of my 3D point cloud. Thanks.